Hello everyone. Today I am going to start your lecture on AC theory, which is a part of the video series lecture of circuit theory. So here we'll discuss about the waveform, cycles and time period, angular frequency, amplitude, peak to peak value and the mean to peak value, phase and phase difference and instantaneous value, average value, root mean square value and how it is related, form factor, and then we'll discuss about how the resistance and current dependency on each other in resistive circuit, purely resistive circuit, purely inductive circuit and purely capacitive circuit, and then inductive and resistive circuit, combination of them, and the inductive, resistive and resistive circuit and the resistive and capacitive circuit together. And in this series we'll discuss about the variation of the AC waveform, how the AC waveform look like. It's a alternating sinusoidal figure here, and you can see an alternating quantity changes continuously in magnitude and alternates in direction at regular interval of time. You can see that the wavelength of this waveform is from 2 conjugative, peak to peak, crest to crest or trough to trough. So we can able to calculate the amplitude, we can able to calculate the wavelength, we can able to calculate the time period, we can able to calculate the frequency and angular frequency, different things from this graph. So this is the phase initially when it is going to become first time 0 from the starting position, that is the phase. So now we'll hear the different waveform, cycles, frequency, angular frequency, time period, amplitude, phase difference. Okay, these things we'll discuss one by one. So here waveform. A waveform is a graph in which the instantaneous value of any quantity is plotted against time. One complete set of positive and negative value in an alternating cycle is known as the cycle of that waveform. Frequency, number of cycles per second is known as frequency. How many cycles is going to produce in 1 second is known as the frequency. And the time period is the reciprocal of frequency, where we can say that the time taken to complete one cycle, one positive and negative alternatively, that is known as time period. Angular frequency is defined as the number of radians covered per unit time, or you can say the reciprocal of time period is known as frequency. That's why we can write omega is equal to 2 pi into f, where 2 pi is the one complete rotation angle in radian, and the time period I already told you. Amplitude is the displacement from the mean position, maximum displacement from the mean position, or maximum vertical distance reached from the mean position is known as the amplitude. Phase, when first time from the starting position it is 0, and the phase difference when you are comparing the two cycles, two waves, and their 0 point you have to see, and what is the distance between them, that is the phase difference. Peak value, this is the peak is either the maximum value or minimum value on the positive side or the negative side, and that in the waveform you can able to see. Peak to peak, from the higher maximum value to minimum value, that is known as the peak to peak value. And instantaneous value, the value at any instant is known as the instantaneous value. The average sum of the observation divided by number of observation, that is the same formula. You can able to, using that formula you can able to calculate the average value, or in continuous waveform you can able to integrate the data to get the average value. RMS, root mean square, root you have to take, and you have to take the average of the squared quantity to get the RMS value. And then after that, form factor, the ratio of RMS value to average value is known as the form factor. The peak factor, it is defined as the ratio of the maximum value to RMS value of given alternating quantity, is known as the peak factor. So now we'll see the waveform. Here the you can see the waveform is sinusoidal in nature, and the maximum displacement, this is the amplitude and peak value, and this is your peak to peak value, and here you can see the peak to peak value is from the positive maximum to negative maximum minimum. Now one question is there based on this concept. Here an alternating current I is given by I is equal to Im sin omega t. I is equal to Im sin omega t, that is the maximum value here, that is the peak value. Sin omega, omega is the angular frequency, omega 2 pi f. So here I can compare the maximum value, I can calculate, that is equal to, by comparing the I is equal to Im sin omega t concept. So here with the help of the standard equation of the AC waveform, we can able to represent the Im is equal to 141.4 volt is the, sorry, there should be a current, ampere should be there, and that's why 141.4 ampere is the what? Maximum current value. Here there should be ampere. Now by comparing the omega angular frequency, the angular frequency omega is equal to 314 here, and the formula of the angular frequency is 2 pi f. So we can compare the omega with the 2 pi f, and by dividing the 2 pi we can able to say the f is equal to, omega is equal to, f is equal to 50 hertz and omega is equal to 14 radian per second. Okay, 314 radian per second. This should be 314 radian per second on value of omega, and frequency should be equal to 314 divided by 2 pi. So there should be 314 radian per second. Time period is the reciprocal of frequency, as you already calculated the time period by taking the reciprocal of the frequency. Frequency is equal to 50 hertz, that's why reciprocal of the frequency is equal to 1 by 50 is equal to 0.02 second, the unit of time. Unit of frequency is a hertz, and unit of omega is equal to radian per second. Maximum value is known as the actually 141.4 ampere of current, and the instantaneous value at time t is equal to 3 millisecond. You can say 3 millisecond means 0.003 second, and that's why when you are substituting the value of time t is equal to 0.003 second in the above equation of the current I is equal to 141.4 sin 314 t, you will get the value here 114.35 ampere. Now the average value we can able to calculate. The average value can be taken mathematically by taking the approximation of the area under the curve at various interval to the distance or length of the base, and actually you can able to simplify the integration of all the quantity, that is the area divided by sum of observation divided by time. So here I have taken that thing for the interval. For the half interval I have taken, same thing you can do for the full interval also, full wave also. So when I am calculating, we are getting 2 Vm by pi, or 2 maximum value by pi, 2 Vm by pi for the half cycle. For the full cycle this should be 0. Why? Because the positive value and negative value sum should be 0 for full cycle of an AC waveform. Now come to the RMS value, root mean square value. So when you are taking the root and we are dividing by t, that is the mean, and the square Vm square cos square omega t, that is the square. That's why root mean square of the AC value, when you will do the integration, okay, under the square root, and you will get Vm by root 2 when you are calculating for the voltage. But when you will calculate for the current, you will get Im by root 2, and 1 upon root 2 value is the 0.7071. That's why Vm by root 2 is also can be written as 0.7071 Vm. And for the peak voltage, okay, the waveform for the peak, if you have the RMS value, you can able to calculate the peak value also, because the RMS value and peak value or maximum value are related to each other, because I told you that V RMS is equal to Vm by root 2, where V RMS is equal to maximum value by root 2. So if you have the RMS value, you can able to calculate the maximum value. Maximum value is equal to root 2 times RMS value. So now in resistive circuit, how the current and voltage are related. So you can see here, resistance is there, resistor is there, voltage supply, AC voltage supply, this is a symbol of AC voltage supply, and current is going to develop. So as you know, the current is equal to voltage by resistance according to Ohm's law. That's why I can say I is equal to V by R, and V is equal to Vm sin omega t divided by resistance, and you can able to write in polar form as well. So here I am sin omega t and I am angle 0, because the here starting point is 0 only. So you can see that the AC waveform going to start from 0, and therefore the no phase difference between the voltage and current waveform. What is the meaning of that? The voltage and current waveform simultaneously going to become 0 at every point. So that's why there is no phase difference between the voltage and current waveform at every point. But you can see that the peak value of the voltage is greater than the peak value of the current, because here we are dividing the voltage with the resistance value. Maybe the resistance is greater than one value, and hence the peak value of the voltage is going to decrease. Okay, so now in inductive circuit, actually in resistive circuit, voltage and current are in same phase, and therefore the phase difference is 0. As phase difference is 0, power factor is 1. What is power factor? Power factor is the cosine of the phase difference between the voltage and current. The cosine of the phase difference between the voltage and current, the phase difference between the voltage and current in the resistive circuit is 0, as we already seen. That's why we can able to say that cosine of the 0, cos 0 value is 1. That is the power factor value for the AC waveform in pure resistive circuit, and it is a factor which we are using to calculate the power. That's why name as power factor. So here V is equal to Vm sin omega t in AC circuit, and when we are calculating, this is the inductor connected in the AC waveform, we are giving the AC supply, inductor is there and current is there. We have to calculate the value of current, because I want to relate the voltage and current, how they are dependent to each other, how the variation going to take place, how is the phase difference between them, which voltage waveform is leading or current waveform is leading, we have to see. So that's why we can able to find out the value of the current in the inductive circuit, purely inductive circuit, by applying the voltage formula, that is 1 upon L integration of V dt. So if you integrate the voltage value of voltage waveform Vm sin omega t and divide them by L, you will get the value of current. That current value you got Vm by omega L minus cos omega t, and minus cos omega t is the, you can able to represent in the sine form as well by taking the omega t minus pi by 2, because sine omega t minus pi by 2 is equal to minus cos omega t, and therefore we can able to write down I is equal to Im sine omega t minus pi by 2. Yeah, you can compare that the voltage is equal to Vm sine omega t and current is equal to Im sine omega t minus pi by 2. The phase difference between the voltage and current is pi by 2, and current lags with respect to voltage by an angle pi by 2, and that lagging effect of the inductor is actually can be seen in the waveform here. The waveform, you can see the voltage is actually going to start from 0, and but the current phase difference, current is actually going to start from the 90-degree lagging. The lagging effect is there due to the inductor in this circuit, and you can able to draw the phasor diagram. Means what? Voltage variation. You can draw the voltage here. Inductor voltage is 90-degree here, and the current is actually 90-degree lags. Current diagram phasor is actually 90-degree lags with respect to voltage, and that's why this is known as lagging circuit. So now we'll go for the capacitive circuit. Here the capacitor is given supply from the AC, and here AC supply is the same, V is equal to Vm sin omega t, and you can see that the current is equal to, the formula of the current about around the capacitor is equal to C into dV by dt, where C into d by dt of Vm sin omega t. So if you differentiate the sin omega t, you will get the cosine value, and that V omega c Vm cos omega t. But we have to compare the input waveform Vm sin omega t with the output of the current value. Current is equal to omega c Vm cos omega t. We have to compare the voltage and current. If you will apply the trigonometry concept, cos omega t is equal to sin omega t plus pi by 2. That's why the leading effect is there. The leading effect means the current is going to lead with respect to voltage in the capacitive circuit, and the capacitive circuit current is having the pi by 2 phase difference with respect to voltage, and that pi by 2 phase difference you can see in the phasor diagram as well. So here the voltage across the resistor, or you can see that the current is actually leading with respect to voltage by an angle pi by 2. Here the voltage and current are perpendicular to each other, and current is ahead of the voltage. That means leading effect is there due to the capacitive circuit, and capacitor is going to give the leading effect to the current, where current and voltage are having the phase difference of pi by 2. We already seen in the waveform, we have already seen in the phasor diagram, we already seen through the equation by differentiating the relation between the current and voltage. Now we'll come to the questions, how we can able to apply this concept in the questions. So how we can able to compare the parameters, we can able to understand which value you have to choose from the given question, so that you can able to apply the formula, apply the concept. This is very important in this session. So now an AC inductive coil consists of the negligible resistor and 0.1 Henry inductance connected across an AC supply of 200 volt. This 200 volt is the RMS value here, and the 50 Hertz is the frequency. And this, whenever this value data is given to you, you have to understand that this value 200 volt is always an RMS value. If you want to calculate the peak value, you have to find out the relation of, you have to relate the peak value and RMS value to find out the peak value. So now we can see the inductive reactance, RMS value of the current, power factor, and VI equation. So as I already told you, the reactance is equal to 2 pi f into L. So here frequency is equal to 50 Hz, that is the f value. Inductance is equal to 0.1 Henry. So you can apply, you can substitute this value in the 2 pi f L data, you will get the inductance. Now I want to calculate the current in RMS value of current. So you already have the RMS value of voltage, you already calculated the reactance value. So how you can calculate the current? Current is equal to voltage by reactance. So that's why voltage you already have 200 volt, reactance we already calculated by the formula 2 pi FL, that equals 31.42. Maybe any value, depending upon the situation, whatever the questions you have to choose the value, you have to apply the same formula, you have to substitute the value. V by XL is equal to 200 by 31.42 in this case, and 6.37 is the ampere current, because the ampere is the unit of the current. Here the next we have to discuss the power. As I already discussed with you, the power factor, because the VI cos phi is the power, cos phi is the power factor, and cos phi we can able to find out by taking the phase difference between the voltage and current. Between the voltage and current, the phase difference is pi by 2, and that's why the cos pi by 2, everybody knows cos pi by 2 is 0. That's why the power in this inductive and capacitive circuit, pure inductive and pure capacitive circuit, is always 0, because the power factor is always pi by 2. Therefore the VI cos 90, that is equal to 0. Okay, so cos 90 is 0, power is also 0, and the VI equation you can able to apply. As I already told you that the peak value or maximum value is equal to root 2 times RMS value. If you want to calculate the maximum value, the root 2 times maximum value, peak RMS value. What is RMS value here? 200 volt. So root 2 times 200 volt is equal to the peak value. And similarly, if you want to calculate the current peak value or maximum value, that is root 2 times the maximum value, and root 2 times the current you already calculated what, 6.37. You can multiply that one, you will get the 9 ampere current. Okay, so this is your equation. You can apply the concept of the V is equal to Vm sin omega t, and the current is equal to I is equal to Im sin omega t plus pi by 2 in case of capacitive circuit, and minus pi by 2 in case of inductive circuit, because inductive circuit is a lagging circuit and capacitive circuit is a leading circuit. The same thing we'll discuss in the capacitive circuit also. So already I discussed all the things. Here the capacitive reactance to 1 upon omega c you have to apply 2 pi fc, and RMS value of the current same, RMS value is equal to RMS value of the current is equal to RMS value of voltage divided by reactance due to capacitor. Power, you can apply the VI cos phi. Power factor is 0, that's why power is also 0, and V and I equation you can apply the same formula. V is equal to Vm sin omega t, and current is equal to Im sin omega t plus pi by 2, because this is a leading circuit. So as we already discussed the pure resistive circuit, pure capacitive circuit, pure inductive circuit, we can discuss the RL circuit as well. We can able to combine them, we can connect them in resistance, resistor and inductor in series or in parallel, but in this case we are going to discuss about the series combination of the resistor and inductor when connected together. And as you know, the inductor gives the lagging effect, that's why in this series combination of resistor and inductor also have some lagging effect, and lagging effect you can see in the equation where the voltage and current, if you find out the net voltage, that lags, actually current lags with respect to voltage with this equation. So when in RL circuit, RL series circuit, the net impedance we can able to calculate by taking the square root of resistance square plus reactance square, and by drawing the impedance triangle. Here the resistor is there, inductance, the reactance is there due to inductor, both are connected in series, therefore net impedance is actually the resultant, that is the you can apply the Pythagorean theorem also. So here to find out the impedance value, where square root of r square plus xl square, and sin phi is equal to what? So cut over, you know, the opposite by hypotenuse is the sine, adjacent by hypotenuse is the cos, and the opposite by adjacent is the tan. So we can apply the value according to the situation requirement. We can able to choose the different trigonometric ratio. Thank you. This is for today.